Welcome to this explainer. Today we're looking at a massive technological threshold that was just quietly crossed. Most of the world completely missed it, but trust me, it is going to fundamentally reshape everything, from the security of your personal bank account to how we actually tackle the global climate crisis. We are officially talking about the dawn of the quantum computing age.
Okay, let's dive into this. On February 9th, 2026, while most of us were probably just scrolling through social media or going about our daily routines, everything changed. Google's quantum AI team didn't just build a faster chip, and they didn't just randomly add more processors. They solved a problem that physicists have literally been calling impossible for decades. What used to be this theoretical science fiction concept was just transformed into a completely concrete engineering problem.
Section 1. The 2026 Quantum Breakthrough, the Stealth Milestone.
So the crucial point is understanding something called the quantum threshold. For 40 years, quantum computers have been incredibly, almost unbelievably fragile. They're so sensitive that a truck driving by outside the lab could literally destroy a calculation. The old logic was that if you added more quantum bits or qubits to a system to try and fix those errors, the sheer overhead of coordinating them would actually create more errors than it solved. The quantum threshold is that magic tipping point where adding more coordinating qubits finally begins to reduce calculation errors instead of multiplying them. And achieving this below-threshold error correction, that is a milestone 30 years in the making.
Think of it like this. Imagine you're trying to whisper a secret to a friend in a really crowded, noisy room. Every time you pass the message, it gets a little more corrupted, right? Well, that is traditional quantum interference. The solution here was to use multiple qubits working together as a team. It's like having multiple people pass that exact same message together, so if one person gets it wrong, the others can instantly correct it. When they scaled their grid of qubits from 3 by 3 to 5 by 5 and then 7 by 7, the errors didn't multiply. They actually cut in half at each step. One logical qubit lived twice as long as the best single physical qubit that built it.
Section 2. How quantum actually works. Beyond binary logic.
Classical computing operates on deterministic bits. It's a world of absolutes, zeros and ones, driven by standard Boolean logic and programmed with traditional languages like C++ or binary. But quantum computing, it's a completely different beast. It uses probabilistic qubits that rely on mind-bending physics like superposition. Think of it more like a spinning coin rather than just heads or tails. But here is the absolutely amazing part for developers. You don't actually need a PhD in quantum physics to use it. Modern frameworks like IBM's Qiskit allow you to program these quantum states using familiar languages like Python. We're already building the bridge between everyday classical code and quantum physics.
Section 3. The ultimate problem solver, a $1.3 trillion upside.
McKinsey estimates that quantum advancements could generate up to $1.3 trillion in value by 2035. That's trillion, with a T. We are talking about solving problems that are currently mathematically impossible for even our best classical supercomputers. Imagine simulating molecular interactions so perfectly that we can design electric vehicle batteries that fully charge in just 5 minutes. Or discovering entirely new chemical catalysts for carbon capture that could lead to gigatons of emission cuts. It could even optimize the Haber process for global fertilizer production, drastically cutting energy use, and allow us to run climate models so incredibly complex that we could predict natural disasters months in advance. It is, without a doubt, the ultimate tool for human progress.
Section 4. The looming security threat, breaking the code. But as with everything, every massive technological leap has a shadow, 19%. I want you to take just a moment and let that number sink in. According to the Global Risk Institute's Quantum Threat Timeline report, there is a 19% probability that quantum computers will completely compromise existing encryption schemes, like RSA and ECC, within the very next decade. That means the encryption currently protecting your digital banking, your private healthcare records, and secure government communications could be completely shattered.
And what's really scary is that the threat isn't just somewhere off in the future. It's happening right now through a terrifying strategy called Harvest Now, Decrypt Later. Basically, nation-states and cybercriminals are currently intercepting and hoarding massive amounts of encrypted data. Sure, they can't read it today, but they're storing it on servers, patiently waiting for the day quantum technology matures enough to slice right through it. Your sensitive data from today is already a target sitting in someone else's vault.
And this brilliantly illustrates the urgency of the situation, defined by something called the Mosca inequality. It's a pragmatic framework that states, if the shelf life of your sensitive data, plus the time it actually takes your organization to migrate to a new security system, is greater than the time it takes for quantum decryption to arrive, well, your data is already at risk. The transition to post-quantum cryptography isn't a someday project. It's an immediate, critical necessity.
Now you might be thinking to yourself, well, I use decentralized technology like blockchain, so I'm totally safe. Not quite. While blockchain is highly decentralized, its underlying ECDSA signatures make its quantum resistance fundamentally broken when you compare it to new post-quantum cryptographic algorithms like Kyber or Falcon. The entire foundation of digital trust as we know it has to be completely rebuilt from the ground up.
Section 5. Ethics and the Divide. The Unspoken Costs.
We also have to consider the energy paradox here. The processors required for quantum computing are so hypersensitive, they have to operate at a fraction of a degree above absolute zero. That's around 20 millikelvin. The cryogenic cooling systems needed to maintain these temperatures consume massive, staggering amounts of grid electricity. As this quote perfectly highlights, we are building machines designed to solve climate change that might actually accelerate energy consumption in the short term, especially as every major Fortune 500 company races to build their own quantum data centers.
Furthermore, there is a very real looming quantum divide. According to the World Economic Forum, 60% of developing countries lack even the basic infrastructure necessary for standard digital transformation, let alone something as advanced as quantum computing. If quantum technology remains concentrated entirely in the affluent global north, we seriously risk deepening global inequality. Under-resourced regions will be economically marginalized and structurally vulnerable to cyber attacks, completely unable to defend themselves against adversaries wielding quantum decryption.
Section 6. The Quantum Timeline, a window for action.
Let's move to and see how this builds across a very rapid timeline. It really falls into 3 phases. Phase 1, right now from 2026 to 2027, is the scaling race. Every major tech company knows the math. It's just a sheer engineering sprint to scale up qubits. Phase 2, entering 2028, is when quantum advantage goes mainstream. We are going to see commercial applications in drug discovery and materials science that classical computers simply cannot compete with. And Phase 3, heading into 2030, is the quantum divide. This is when the harsh reality hits. Businesses that integrated quantum capabilities will mathematically outcompete those that didn't, basically rendering the laggards completely obsolete.
So, what can we do? Here are the concrete action steps you need to take right now. First, organizations must immediately audit their current encryption systems. If you rely on RSA or ECC, you need a migration plan today. Second, identify the deep computational bottlenecks in your business. Where are you currently relying on basic approximations because the exact math is just too expensive or time-consuming? That is your quantum opportunity zone. Third, transition to NIST-approved quantum-safe algorithms. And finally, on a personal level, start learning. Dive into libraries like Qiskit or Cirq. The pioneers who actually understand the space today are the ones who will write the rules for the next decade.
The fundamental mathematics governing our world, our security, and our limits of innovation are quite literally rewriting themselves as we speak. The breakthrough is real, the threat is absolutely verified, and the timeline is accelerating at AI speed. The math is changing. So, are you ready for the quantum age, or are you still calculating? Thank you so much for joining me on this explainer. Stay curious, stay prepared, and I'll see you next time.